in another one of our remote hosts, Addie Pollock.
Hey, Addie.
Hi.
Hey, how are you?
I'm good. How are you there?
Awesome. Thank you for joining us in the middle of the night, your time.
Absolutely, my pleasure.
So, what are your thoughts on Ignite so far? What's been good? What was surprising to you?
Well, I think all the new announcements, all the new technologies. Well, I'm especially waiting to the Synapse session
That's right.
today. So I'm super excited about that one. And of course, all our furry friends that join us. And I'm still waiting to see when Easy is going to get a cat. I mean, what's going on with that?
Okay, I'm just gonna go and just put it on record right now, just telling all of you, Thomas, you should not get Izzy a cat. You should get her 2 cats. Because then, while both of you are working all the time, the cats can keep each other company and they won't constantly be climbing on you. So just letting you know, you should get Izzy 2 cats. Okay, 2 cats, hashtag. Just saying. Poor Thomas is gonna wake up like, why has everyone at Ignite become fixated on my cats? So Addie, thank you so much for joining us, and we can't wait to watch your segment. Thank you.
Thanks. Hi, I'm Addie Pollock, and today I get to talk with you about something I'm truly passionate about, functional programming, specifically how reinforcement learning and Azure are transforming autonomous driving. Join me and Alex Kendall, John, and Aditya Sharma to learn more about this. Hi, everyone.
Hi, Addie.
Hey. Hello.
Hello. All right, so in this panel today, we're going to talk about the partnership and bleeding edge technology. It's about a startup that disrupts the already innovative world of autonomous system through its unique end-to-end reinforcement learning-based solution. They solve some of the most formidable challenges in autonomous driving. Like I mentioned earlier, we are joined by Alex, a Wayve CEO, to talk about how they partner and leverage Azure technology to accelerate their vision. And we're going to talk today with Alex, Aditya, and John to share with us how they build this partnership and make it a success. Alex, let's start with you. What is Wayve?
Hi, everyone. I'm thrilled to share with you a bit of a sneak peek into the future of autonomous driving. So Wayve is creating autonomous driving that is driven by artificial intelligence. I think it's becoming more and more apparent to many of us in the industry that the traditional approach to self-driving, one that relies on HD maps and hand-coded rules, it's not going to scale to the complexities of the urban worlds we live in. So as you can see in the video, Wayve is really pioneering a new approach, a next-generation approach that uses AI to drive through experience and data using reinforcement learning and computer vision. It's really a bit like how you and I would learn to drive as a human. We firmly believe that this is the future of autonomous driving technology, and we're building a system that can learn to drive like a human, something that can learn to drive from London to Paris to New York with no extra re-engineering, a bit like how you might do if you go on holiday to one of these destinations. So we really aim to be the first to deploy this technology in 100 cities worldwide. It's been an exciting journey so far. When we got started in 2017 and 2018, our team was the first to demonstrate reinforcement learning driving on a real-world autonomous vehicle. This was one of the first times we've seen reinforcement learning leave the realms of simulation and go into the real world. And so today, I'm absolutely thrilled to share a bit more about how we're scaling this and how through our partnership with Microsoft Azure, we're scaling this technology to fleet scale and operating these autonomous vehicles throughout roads in the United Kingdom.
Alex, this is an exciting partnership. Can you please tell us more about how the system performs on the road?
Yeah, absolutely. So our system has learned to do some basic driving maneuvers like lane following and some more complex ones like roundabouts and basic traffic lights. We're now learning how to do things like multi-lane roads and some more complex driving as we scale it through the driving curriculum. We're really building a driving school for robots. One of the most exciting things that our system has done to date is it's shown that we can train it on driving data that we collect in London, and we can teach it how to drive in London. And we've been able to take our vehicle to a new city in the UK, one like Cambridge and Birmingham, and show that it can drive in these environments without any extra experience from that city. And this is really how it's going to scale. we don't envision a world where to go to each new city, we need to build a new set of rules and maps for how a vehicle should drive. But we want it to learn how to drive in a really intelligent way, one that can understand driving concepts like humans can, and ultimately scale. And so that's what we've been able to show so far.
Interesting. And you're doing extensive usage of machine learning, right? So what is Wayve fleet learning system like, Alex?
I'd go as far as saying that I think machine learning is the only way that this technology is going to work and scale to humanity's needs. Driving is so complex, as many of you will know, and I question whether it's possible for humans to actually hand engineer a method and an algorithm that can do this by hand. So I think we've got to rely on data and machine learning to be able to achieve this and get something that that rivals the human brain. So we rely on a fleet learning approach, one where we're training a system to drive with one giant neural network. It really does operate end to end, all the way from inputs to outputs. We feed our system the camera data, the sensors on the vehicle as the input, and we have a giant neural network with tens of millions of parameters that learns to predict how to control the vehicle. And it's this system that we are really scaling and training with Azure's technology. To be able to do that, it requires a very large-scale training system, one that can train over petabytes of video driving data. And we have a loop that continuously optimizes this. We call it a fleet learning loop, and it consists of data ingest, training these systems at scale, validating them in simulation, and then deploying them on the road. And running this loop as fastly and as efficient as we can is what's really going to make this possible. So I just talked about a few parts of it I think are quite interesting. The first one is around ingest. So we almost have too much data, and it's really important to choose the right data you want to ingest to learn. It's a little bit like teaching a child at school. You don't want to give a child examples and knowledge that are too easy, otherwise they'll get bored, or if it's too hard, they'll get frustrated. And it's similar with a machine learning system or a robot. You want to give it data that is on the boundary of knowledge that really pushes it forward. And so we don't want to give it lots of just lane following examples because that's too easy. But then again, things like three-point turns and complex traffic maneuvers on their own are too complex. And so we want to have a balanced distribution of data to ingest. So it's really about picking the right examples. And then training is all about learning to copy humans with imitation learning, and then using reinforcement learning to become superhuman by learning from mistakes through safety driver intervention. And it's this continual optimization that we need to run. It's amazing the scale that we can achieve with Azure. We're really pushing throughput of this loop to be 25 gigabits per second per GPU machine, and that's what's required to really bring this technology to market.
That's awesome. Aditya, how can Microsoft technology support this scale of machine learning training?
Yeah, so I actually just want to start off with Alex mentioned petabyte scale. So just for people who are viewing, just want to put in context what a petabyte is, right? So when we talk about a petabyte, where if you had a 12 megapixel camera, let's say, we're talking 250 million pictures, right? And then if you want to talk about videos, we're talking 250,000 HD movies. If you had a MP3 file, which is 1 petabyte in size, that would take, if I played it now, it would take 2,000 years to complete. So that's just 1 petabyte, by the way. And for autonomous driving workloads, we're talking about ingesting multiple petabytes every day. And then bringing this data to the cloud, and then running all the processes that Alex talked about: large scale simulation, training, validation, highly distributed jobs which would require thousands and thousands of GPUs and CPU cores. And then when we talk about release cycle in software, where automotive is an industry where release cycles have been anywhere between weeks to months, and for autonomous we have to bring that down to like hours to days. And so all of this is basically what we've been focused on at Azure. We want to stay ahead of the curve. We want to make sure that we're delivering all these requirements. Because we're talking petabyte scale now, but soon, by the time autonomous is deployed at scale, we'll be in exabytes. So our basic goal is, when Alex calls me next week, let's say, and says, "Hey, we're working on this new and exciting project. How can Azure support us?" We want to say, look, we can support you today, instead of giving an answer like we'll be able to do this in six months to a year, right? So that's really what we've been trying to do, just making investments in our products across the platform in Azure, just making sure that we are always enabling that scale.
Awesome. So exabyte is definitely coming, specifically for the autonomous driving systems. All right. So we need to deal with data. We need to deal with data strategy. So Alex, what is Wayve data strategy today?
Well, I can't emphasize enough the scale of this approach that we're really building here. It truly is, exabyte scale, as Aditya says. But you might be surprised to learn it's not just the magnitude of data, but it's the diversity that really matters. I mentioned that we needed the interesting data examples to train these systems and build a learning curriculum. Well, to get really diverse driving data, you do need a very, very large data source, but it's important you can select the right data from that data source. So our strategy is really to work with fleet partners to deploy 4G self-driving data collection devices on very large-scale fleets. And it's this network of connected vehicles and of self-driving data collection devices that's going to enable us to do this. These devices on the edge can run algorithms to really select and curate the data. And then through Microsoft's Internet of Things technologies and through connections through to Azure Cloud, we're able to link this data through back to Azure to support the fleet learning loop. And so this is a really neat strategy because it gives us access to enormous amounts of data, but also lets us curate it into the very specific learning examples we need to train our autonomous driving systems. And it also lets us work with fleets across many different mobility verticals. So we're particularly interested in things like ride-hailing, logistics, and public transport. And we're building a system that can learn to move all of them. This data collection system can also enable next generation opportunities in things like logistics, transportation, and safety. And ultimately, it's going to enable us to capture more than 5 million images per second across our entire fleet.
All right, cool. So we have one last question. John, this question is for you. So how Wayve-Microsoft partnership looks like going forward?
Yeah, so I mean, this is a really strategic partnership for us. I think there's a great opportunity here to disrupt the industry. Autonomous driving is pretty disruptive anyway. And then when you consider that what Wayve is bringing is potentially a much leaner, more adaptive way of being able to introduce autonomous driving, I think the impact on the market can be huge. I think in a short time, we've already been able to expand the scope of how Wayve makes great use of Microsoft technologies. The fleet data collection based on Azure IoT that Alex was just talking about, and the control panels in the Wayve fleet that are using Surface are great examples. And I think we're going to continue to work together to find ways of making Wayve increasingly more efficient and effective as they roll out their technology. And our goal, obviously, ultimately, at some point, is to start working together on taking this game-changing, lean and flexible approach to autonomous driving to the automotive market.
Thank you so much, everyone. I learned so much today, and I definitely want to learn more on your partnership specifically, and also about what Microsoft offers for this specific industry. It was lovely and a lot of fun, and I'm always happy to learn about petabyte scale machine learning systems, exabyte scale machine learning systems, and everything that comes in the future. All right, thank you again, and thank you for sharing your fabulous partnership story, and hope to see you soon again. Thanks.
Thank you so much.
Thank you.
All right.